Welcome to our special topics computer graphics course. It's listed under both electrical computer engineering and computer science. It's listed both as a 400 level and a 500 level special topics. We'll talk about the differences between 400 and 500 level as we go along. But for now, welcome to the course. This course is the outgrowth of a course I've been teaching for many years in computer graphics, although it's as you will see through the course, it's changed greatly in this version. But the target audience is primarily seniors, graduate students in computer science, computer engineering, but pretty much any other student in engineering or the sciences or mathematics who has at least reasonable programming skills should be able to benefit from this course. Okay, this particular version is based on a new edition of the book that I and my colleague Dave Schreiner have called Interactive Computer Graphics. It's been around a long time. We're now on the 7th edition, and actually the name here should really say WebGL instead of OpenGL, because that's really the major change. We've now switched from a standard OpenGL version that we used for the first 6 editions to something that's totally web-based, and we believe is making major changes in the field, which is why we're doing this course, and it's going to be very different from the course that has been taught in previous semesters. What we'll do is we'll cover the first 7 chapters of the book, hopefully in fair amount of detail. We'll go over the chapter by chapter in a little while, and hopefully we'll have time to survey the remaining chapters in the book, at least through the 11th chapter, perhaps the final chapter. But let's at least start with what we're going to do this week and how we're going to do it, and what the background you'll need is, and what I hope you'll be able to do in this course. So what I've done, unlike previous courses, is I've broken the lectures up into shorter lectures that'll depend somewhat on the topic. They'll be usually between 15 minutes and half an hour. So for this week, there's 5 short lectures. This obviously is the first. I want to just introduce the course, some references, what kind of work I expect. Then I'll go through a more detailed outline and some examples in the next lecture. Third lecture this week, I want to give a full example in JavaScript. One of the major changes that you're going to see here that will seem perhaps a little unfamiliar at first is that we're using JavaScript because JavaScript is the language of the web, and WebGL is designed to work within JavaScript. It's in fact the JavaScript implementation of a version of OpenGL. So we'll be programming in JavaScript. I don't think that'll cause major problems for any of you. I'm going to assume that most of you have not really done any JavaScript, and that was my situation when I started doing this edition. So we'll look at a little of that as sort of introductory stuff. We'll go through a very, very simple example. Then for the next 2 lectures for this week, we'll get into, well, what really is computer graphics? I mean, it's a fairly broad field, and what parts of it do we want to talk about? And that'll lead us into a discussion of how images are formed, because what we do by computer in computer graphics is very much emulating what we do by image formation processes, whether it's image formation by a simple camera or it's image formation through your visual system, through your eye and your optic nerve, and that we'll see that all of those ideas are ideas that get carried directly into computer graphics. Now, for what I want you to do this week, and I'll go through some examples a little bit later in probably the succeeding next lecture, is to first I'd like you to read the first chapter in the book, and I'd like you to go through some of the exercises that are on the web, primarily so that you'll make sure that your web browser is one of the newer web browsers that'll run WebGL, and also to give you an idea what we're going to be doing in the course. Now, before I go on, let me say something about the book. The book is not going to be available at the bookstore, probably what I've been told now, and I'm recording this in early January, probably won't be available until mid-February. I've worked out with Addison Wesley that they will duplicate at least the first 3 chapters of the book, and I send me those about 30 copies that I'll distribute. We'll make probably most of them I could distribute through, if you're on campus, through the CS office. For those of you that are not on campus, we'll figure out a way to get you a copy of those chapters. So you should be fine for the first month or month and a half without having a physical copy of the book. You'll have a pretty almost final version that's being duplicated right now. Okay, so let's look at what we're doing today. Give you a little bit of an overview and what kind of background I assume you have, and I want to give you some references that especially some web references that you'll be able to use. First, my contact information is you can get me by email almost always at angel@cs.unm.edu. My web page will have a fair amount of material under book support. We'll also put up a separate site for the book. In a few minutes, I'll show you the site that has a lot of example code on it. But that'll at least get you in touch with me. The various forums that are available through Learn, we'll try those out over the first couple of weeks. My plan is I'll probably be on campus about once a week, and so I should be able to meet with a lot of you periodically to discuss the class. I'm usually online. But if the tools in Learn don't work out well, we can use Google Hangout or some other Skype or something to have conferences. So let's just see how that works out. Okay, so objectives for the class. Okay, I'm going to do a very broad introduction to computer graphics. One of the arguments I always make is that computer graphics involves software, it involves hardware, it involves applications, and you really need to be able to say something about all three. If you have an application that you need to solve, somebody is going to write the software to do it, but if you write the software, you need to know what the hardware is capable of. Likewise, if you're a hardware designer, you need to know what kind of applications people want to do using computer graphics. So there'll be elements of all three in this course. One of the things that characterizes this course, and characterized it really when we started doing OpenGL about 15 years ago, is that we take a top-down approach. And so the idea is to get you programming applications, primarily three-dimensional applications, as soon as we can. That's in contrast to the way computer graphics used to be taught, where people would start down at the lowest level, talk about pixels on the screen and how do you assemble those pixels into lines, how do you do things like fill the insides of triangles and rectangles. And students were usually really disappointed in those kind of courses because they never got to do anything close to all the exciting things that they were starting to see in movies and animations and television and games. And so we adopted this top-down approach, starting with OpenGL, which pretty much everyone does now. But what's changed dramatically over just the last couple of years is that the graphics capability that's available on virtually every computer and even available on your cell phones is based on having a graphics processing unit that in many cases is more powerful than the central processing unit on the computer, and it's specialized for doing graphics operations. And so the code that goes into that GPU are called shaders, and we'll talk about the architecture in a little bit. But almost everything that we do now, the idea is not to write a program that does something within the central processing unit, which would have been how we would have approached things just a few years ago, but rather to have everything done inside of the GPU through special little shader programs that use a language called GLSL, which is very C and C++ like, and can do some wonderful things. So everything we're doing is based on a more modern version of OpenGL, and in particular the version that runs in most of the browsers, which is called WebGL, which integrates with HTML5. In particular, it's part of the HTML5 canvas element, and now should be available in almost all recent computers and pretty much in all of the browsers, and recently including Internet Explorer, which didn't support it until the present version. We'll talk more about that in a bit. Prerequisites for the course. Well, really, they're pretty loose. I expect everybody has pretty good programming skills, whether it's C, C++, Java. I really don't care which. I just really assume that everybody has the ability to write fairly complex programs, 500 line, 1,000 line programs, maybe, equivalent to the second or third course that you would take in computer science or computer engineering. We'll use some basic data structures, but really, really very, very simple. We'll use arrays, so you'll need to know a little tiny bit of linear algebra. We'll use linked lists. We'll maybe with some of the applications towards the end, we'll use simple tree structures. So kind of if you're a CS major, kind of the equivalent of 251 and whatever the equivalent number is in computer engineering, but no complex data structures. Geometry is probably the best background that you can have, and that goes back to high school. I mean, so much of what we're going to do is really based on geometry. And likewise, linear algebra, very simple linear algebra, multiplying matrices, adding matrices together. What we'll find is that the size of the matrices that you're going to use is generally doesn't go beyond a 4x4 matrix. The majority of work we'll do is with 3x3 and 4x4 matrices. So we're not interested in very complex schemes for how do you invert a 100 by 100 matrix or anything like that. They'll all be very specialized and small kinds of matrices. Now, in terms of the course that some of you might have had, and I put that on the notice, I didn't put down CS EEC 412 as either a pre or co-requisite. There's a lot of overlap, but I've talked to the instructors, I've talked to a lot of the students about it. There's a lot of overlap in what we're trying to do, but the approach we're taking in this course is very, very different. What I feel is that you probably shouldn't get credit for both 412 and this course. On the other hand, I think there's going to be some special cases, and I've talked to some of you. So if you're in that situation, send me an email and we could talk. I would, the general, I think, rule I'd apply is that someone who's already had 412 I'd ask to do a much larger project or a specialized kind of project that really would not be used that much of 412, and there is a lot that's different in this course from 412, fundamentally because it is very non-traditional so it's very shader based and it's very web based, and we'll do a lot more interaction than probably you did in any recent version of 412. Grading, what I'm going to do is give out 3 assigned projects. The first one will be fairly simple, and it's really to make sure that you have the requisite programming skills and that you can actually, things will work within your own browser, and just to check that out and get you going. The second project will be interactive and hopefully have a little 3D in it. And the third one will really be a fundamentally three-dimensional project. And hopefully we'll get those 3 done in approximately the first half of the semester, and then the term project will be about 50% of the grade, and you're going to get to pick it. So one of the things I tell people in this course is, in some sense, you get to choose your own grade by how complex and how much effort you want to put into your project. And I'll have suggestions for projects. I'm hoping you'll come up with suggestions of your own. I have some faculty and researchers in the engineering college that want to work with people in this course and have projects where they can use some people with some graphic skills. So we'll work that out as the course goes on. If you look at my website, I'll use this as the class website. It's probably fairly empty right now, but I'll be adding a lot of material to that as the semester goes on. I'll put assignments and projects and other information there. So let me just repeat a couple of things before I get to references about, again, why this course really is different. And the main thing is it's really based on the use of shaders. And when you start using shaders, all of the functions that if you were using OpenGL previously, most of the standard functions have been deprecated or removed. So if you're familiar with functions that say vertex, 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 begin a list of vertices, end vertices, have a bunch of matrix function in it, a bunch of viewing functions, that stuff's all gone. And it's all gone for a reason that that was called a fixed function pipeline. That when you specified some geometry, it went through a fixed set of operations, didn't really need you to use shaders to do it, but it didn't really use the capabilities of a modern graphics processing unit. And once people started realizing the power of GPUs, they're making supercomputers out of GPUs, they said, we really should eliminate all of this from core OpenGL and have OpenGL become fully shader based, which is the direction that we've gone in. The previous edition of my book was all shader based, but it wasn't web based. So now we're going to also make it web based. And then we say with the web, well, the web is really what's happening. If you want to have an application, you want your application to be able to run in a browser, and that's what we're going to be able to do. So one of the things it does is it enables you to use your local hardware. So you will be able to have an application or use somebody else's application that's just a URL on some server somewhere. But when you click on that URL, the code is actually going to run in your hardware, making use of your graphics card. And that's a huge advance in graphics technology. Second, in terms of making things work, there are no more system dependencies because everything is based in browsers, and all the browsers pretty much run the same thing. So we don't have to worry about whether you're on a Windows machine, whether you're on a Mac, whether you're on Unix. If you develop some code on Unix and then you want to run it on Windows, you have all kinds of problems. All that's gone because everything should run in pretty much every browser. And most of the code that I've developed for this class runs on my cell phone. A number of the Android phones, the browsers will support WebGL, and so I can demo a lot of code on my browser, which is kind of impresses people. Okay, let's talk about a couple of references now for the class. These are a set of books. Obviously, my book with Dave Schreiner, Interactive Computer Graphics. It's the 7th edition that you want, which will be coming out, as I said, in February. If you want information about OpenGL in general, the OpenGL Red Book, the OpenGL Programmer's Guide, Dave Schreiner is now the author of that. It's in its 8th edition. It's probably, of all the programming guides, it's one of the best I've ever seen, but it's really not particularly aimed towards WebGL. But if you ever have a question about an OpenGL function, that's the place to go. WebGL is based on OpenGL ES2. ES stands for Embedded System, so it's a somewhat stripped down version of OpenGL that was meant to run in handheld devices, which then became smartphones primarily. And so a lot of the code that you see running in phones uses OpenGL ES, which is usually you write programs in ES using C or C++, but WebGL came along, and WebGL is a JavaScript version of OpenGL ES. So the functionality of WebGL is based on what's in ES, but is fully JavaScript. So recently, there's a new WebGL programming guide. All of those first 4 books are Addison Wesley books. Recently, there's a couple of WebGL books that have come out. One, the WebGL Programmer's Guide. Another is WebGL Up and Running. And I've looked at both of them, and they're okay. They have some good examples in them. The book that I recommend highly if you haven't used JavaScript is JavaScript: The Definitive Guide. It's a Riley book by Flanagan. I think it's probably in about its 6th edition now. I found it to be, just for a programmer, to be a wonderful way to get into JavaScript. It's a big book, but the explanations are clear, and almost everything you'll need to know about JavaScript is somewhere in that book. And there are many others, and there's an awful lot of web resources for learning the JavaScript that you'll need. But if you're a Java or a C++, C++ programmer, you should be able to pick up basic JavaScript very, very quickly. Okay, a few web resources to finish today. My website. Now the examples in the book, I'll finish with a couple of those in a minute. I just put up a whole bunch of them under WebGL 7e for the 7th edition, and it's organized by chapters, and there's examples. Pretty much they're the examples from the 6th edition that I redid for the 7th edition, and a bunch of new ones. OpenGL.org is a good site to find a lot of information, and same thing with the Kronos site. Kronos is the group that sets the standards, and between the OpenGL site and the Kronos site, you should find lots of tutorials, lots of other examples on those two sites. If you simply want to check your browser to see if it'll run WebGL, just go to getwebgl.org and it will come up and tell you, yes, WebGL runs on your system, or it doesn't. Chrome Experiments has some incredible examples of what's possible in WebGL. So on one hand we say, well, it's based on a stripped down version of the full OpenGL, but the stripped down version can do an incredible amount of stuff. And if you look at Chrome Experiments WebGL, you'll see some amazing examples of the kind of things we're hopefully going to talk about in this class. And then there's some learning stuff up on the web. Learningwebgl.com is a pretty good source of some basic lessons on WebGL, but we're going to teach you how to do those things. So let me finish by just going through a couple of examples from my website. Let me switch over to that. Okay, so here's the site. Arranged by chapters, so it's WebGL 7e. So here's chapter 2. So here's our first example is. Now notice that what we're going to do here is I've zipped up everything so you can, if you want to download any of these to your own system, you can. The way I've organized things, and I'll explain that in the next lecture or two, is each application has an HTML file, and the HTML file calls the JavaScript file. The point of that is that the HTML describing what the page looks like and what files have to be loaded, I wanted to keep that separate from the graphics part. So I have all of my applications separated into these two files. So if you click this one, there's the first example. It's a bunch of points that generate a Sierpinski gasket. If you go back a little later in the chapter, this is all in chapter 2, we'll do a 3D version. Here's a 3D version of it. Oh, that's not good. I'll give you a better 3D version here. This is a good 3D version. This is dividing up, recursively dividing up tetrahedrons. It's a fractal, so we'll talk all about that in chapter 2. And you can go on to later chapters. Let me just go up to, say, this one. Let's go up to here. This is sort of where we're going to definitely get up to, and this is an example of, these are all discrete examples where we start doing texture mapping. So here's a texture map. Here's a 2D image mapped onto a cube that's rotating. You can control the rotation if you want, so we'll be doing a little simple interfacing. There's also some color blending going on here. So these are all things that are part of the core of the course, and this is where we're trying to get up to. So go to the site, take a look at it, make sure that things will work on your own system, and we'll end this lecture